finish the DFX. Okay, what is design for excellence? So it's very important to understand design for excellence. If you go for interview, they will ask you what is DFX. So what is DFX, students? Can anyone tell me?
So designing in such a way that you get the best quality product with like least cost,
Okay, then
with least complications, easy to manufacture and assemble, and all those things are considered.
okay, good, Sachin. So as usual, you can see the definition part. Okay, here design for X is a methodology that works towards improving processing in a specific field like manufacturing, then power, then cost, then yield or reliability. What's reliability? Students, can anyone tell me what is reliability?
So it's the ability to produce like good outputs again and again, sir.
Good. So that is reliability is nothing but the we should produce the because we should produce the products, okay, which should design the component, okay, which should have for more life, okay, which should work for more life. So that is called as reliability. Okay, design of components and systems aim to improving the reliability of the construction unit. So this indicates we should produce the component which has high quality. Okay. So then what is cost?
So cost, I think it will be in terms of manufacturing, sir. You need to choose the design in such a way that it can be processed under the machines which you have, and it takes the least time. So you require less power to produce the same particular product, and like the machines, you don't need to buy any extra machines. Like if you can make it under the machines you have.
Yes. So cost indicates the whatever it may be, whatever investing, okay, for manufacturing the products. Okay, like fixed cost, variable cost, everything will come under this cost. So whatever you are investing to produce one product, okay, should be less. Okay, whatever the material you're choosing, then what are the machines you are using. So everything you should consider, and they should be less. So finally, you should produce the products with less cost so that you can give that product for the society with respect to it cheaper. Okay, so that's indicate cost. So we'll come from first. See, everything if you consider the manufacturing, if you consider the cost, if you consider the reliability or whatever, everything it should be good. Okay, with respect to the product, okay, it should have good. So that indicates the excellence. Excellence means the product which you're manufacturing with respect to everything. If you consider like the productivity or manufacturability or reliability, or you can say the serviceability, the safety, okay, then robustness or quality, okay, everything or assembly, everything, okay, it should be excellence, it should be good. So that to make the product, okay, towards excellence, okay, we should use this methodology. So this is called as design for X. If you go for company, they will tell design for X. So design for X indicates design for excellence. So if you come for the first paragraph, okay, here I've written here X stands for different properties of the products. What is different properties? Can anyone tell me? I've mentioned here different properties. So if you go for
So
material,
like you told earlier, no, so it can be the quality of the product. So it can be quality or the design, or with respect to assembly, with respect to manufacturing, or with respect to cost, so
okay,
on.
everything, right? So that is called as properties. So if you come for materials, the properties are yield strength, or it may be the Young's modulus, Poisson's ratio. So these are called as properties for the material, or physical properties, or it may be chemical, it may be the mechanical or electron or electrical properties. So with respect to material, with respect to your the product, okay, whatever the Sachin has told, like cost, reliability, or manufacturing, or it may go for the product of, sorry, the wait for 2 seconds. Okay, so the properties indicates everything. The either it may be cost, or it may be quality, or it may be time producing the products successful time. Everything come under the properties. Okay, so so this is called as properties of the product. So we should improve. So always we should try to give good with respect to all the properties. Okay, we should give in the form of excellence. Then only the customers will be satisfied according to the customer needs. Okay, if you produce the products with the excellence, with regarding to all this, like quality, it may be the cost, or it may be the quality, or it may be design, okay, design of the product, everything. If you give excellence, okay, that becomes a good product, right?
Yes, sir.
So next we can go. Okay, then generally DFX is an approach to product design, then especially directed at maximizing the fundamentals demanded of the product. So you can see that fundamental demanded of the product. So depending upon the demand of the product, okay, we should manufacture the product in every accept. Okay, we should the product quality should be excellent, or the product should be excellent. If you go there, the functionality, what is that by functionality? In the bracket I mentioned functionality and performance. What is functionality? I told you about this. What is function? What is function of the product?
Sir, the ability of product to perform the activity which is it is designed for, sir.
Okay, good. So function means nothing but regarding to the customer needs. Okay, if whatever the customer is asking, if you give if you give that in product, so that's called as function. So it should work regarding to the customer needs. So that's called as functionality. So the main aim of producing the products is, okay, to give the required product to the customers. Whatever the customers asking, we should produce, and it should work in the same way, right? That's called as functionality. And performance. The performance means what? How it performs, right?
Yes, sir.
So after giving to the customers, okay, it should perform well. Okay, so I told you an example of car, okay, which the customers, I want to ride the car, okay, with respect to 1000 kilometers per hour. I want to ride. So that's what is called as what is asking for us, or what is asking for the automobile industry. But we don't know whether the automobile industry can manufacture or not. But the function is to manufacture a car, okay, which should move at 1000 kilometers per hour. So this is called as function. And perform is nothing but whether that car is moving at 1000 kilometers per hour or not, right? So that's called as performance. So after manufacturing the car, okay, once the company gives for the customers, if the customer is riding the car, okay, whether the car is moving at 1000 kilometers per hour or not. So it's called performance, whether it is giving the whatever the customer is asking or not. Okay, then quality, then manufacturability, reliability, serviceability, safety, user friendliness, okay, then environmental friendliness, short time to market. So all these things, okay, you should take care, okay, in this design for excellence. So everything from starting to end, from functional to the short time to market, so everything you should consider. And if you give in the form of excellence, okay, in the term of good, the product is good in every aspects. Okay, if you consider everything, if it is good, so that is called as design for excellence or design for X. Okay, if you go for industry, they'll call design for X. So if you are this design for X, so that indicates, okay, they're telling about all these things like functionality, performance, then quality of the product, reliability of the product, serviceability of the product, safety. Okay, so everything it will come under this design for X. So anyone has any doubt in this?
No doubt, sir.
And at the end, you can see at the same time at minimizing cost. So if you consider all these things, and you should try to minimize the cost. So that is what is called as design for X, design for excellence, or design for X. So in this design for X, the main aim of the design for X is, okay, to give good product. Okay, what are the things what are the things we are going to use, or which methodology we are going to use to give better product for society. Means the product in all the aspects, it should be good. That is called excellence. Excellence is nothing but good. So if you give a better product in all these terms, so that indicates the customers will be satisfied, so that your product will sell well in the market. So your growth, if you take PLCM, that is PLM, product life cycle, the graph, okay, your growth will be very high. Okay, your product can sustain more life, as well as the sales of the product will be very high. Okay, depending upon this design for X. So next we can go for the end. You can see the definition part. The design for excellence is a systematic approach for product and process engineers while designing a product where X represent targeted objectives or characteristics of product or process. I think everyone has understood, right? That the definition. Anyone has any doubt?
So
Anyone
can we
has any
write
doubt?
our own definition, sir?
Yes, you can write.
Okay, sir.
So I'm telling you, you can write your own definition. Okay, you can explain the concept with your own words. Okay, that's your wish. But whatever you're explaining, okay, it should be it should be related to that so that concept. Okay, that's all. Okay. So here you can see design for excellence is a systematic approach for product, right? Okay. So design for excellence is a systematic approach for product and process engineers while designing a product where X represent target objective. What is the target objectives? Who is the target objectives? Can anyone tell
The
me?
customer, sir.
Okay, good. So where X represent targeted objectives. So X is nothing but excellence. So if you give excellence product for the customers, so that indicates okay your sales of the product will be very high. So you can see it in the sketch. You can see the sketch, right? Excellence indicates vision, then inspiration, motivation, ideas, then communication, okay, then passion, innovation, everything will come under this thing. Okay, if you want to give a better product for a society, so always as a product design engineer, okay, always you should be in the motivation, always you should get good ideas, okay, then communication, vision, innovation, passion, okay, then competence, everything, okay, you should consider. Then if you make a good product regarding to everything, okay, then you can sell well in the market, okay, whatever the product. Then you can see design for X types of design, you can see here, right? So what are the different types you can see here?
So
I think
DFM,
yeah.
then DFA also might be there, then design for cost and other things are there.
Okay, good. So in this 7, okay, I think everything we should consider while we manufacture a product. Okay, it is design for manufacturing, design for cost, design for testing, design for maintainability, then design for robustness, then design for supply chain, then design for safety. So these are the main 7. Okay, we should consider. So when we are producing a product, so okay, then we will see one by one. So you should remember all these things. Okay, these are the 7 main different types of excellence. Okay, design for excellence. So we will be considered when we are going to manufacture a product. First is design for manufacturing. Okay, so that indicates design of components and construction systems as a function of machining process. So while manufacturing a product, okay, we should consider all the accepts, the tolerance of the product, right? So if you go for a manufacturing of a car, so how much the parts will be there, how much parts we should manufacture, right? So every product, every product, the parts, okay, the design should be paka, right? I think if they give whatever they mention, okay, we should manufacture regarding to the design, right? The 2D design, they will give 2D design for all the products or all the parts. So it should be 100% okay, right? Then only we can go for assemble, right, students?
Yes, sir.
So that's called design of components. Whatever we are doing, whatever we are first we are trying to convert our ideas into the design of the parts. So we should be clearly mentioning the dimensions neatly. Okay, whenever we go for manufacturing, okay, so when we manufacture the parts, so then we'll go for assembly. So when we go for assembling, go for, okay, if the design if the design dimensions is not okay, then what happens? We cannot assemble the parts. So that is very important. So that is the first condition. That is design for manufacture. That is manufacturing the products. Okay. So then design for cost. What is this design for cost, students?
So like as per the customer requirements, he'll give a certain budget that he needs a product in this range. So as per that, you need to select materials so you are able to produce a product and earn profit with it too.
Good. So this is cost. Then what is design for testing?
So testing can be like the assume you are building a bag, so it should be able to withstand a certain amount of load and all those things, sir. So it is able to have a certain limit that it can withstand that amount of load, so you can design based on that.
Okay, good, Sachin. Anyway, design for testing indicates, okay, what type of load, okay, which is coming on the product, okay, whether the material can withstand that much load or not. So everything will come under the design for testing. So without testing, we cannot implement our product to the market. Then design for maintainability. Okay, what is the design for maintainability?
So I think this might be like at how regular you must need to give your product for maintenance. Like for car, you need to give maintenance for after certain kilometer range. So that might be the case over here.
Yes, yes. So that's called maintainability. So we should mention the maintainability. So example, okay, if you're manufacturing the car, you should tell that, okay, for how much kilometers, okay, how much kilometer, okay, if the car runs, okay, then we should give for service. Example, okay, for every 5 kilometers, okay, we should change the engine oil, right? If you go for the bikes or cars, okay, they will tell for how much kilometers, okay, you should change the engine oil. So that's called as maintainability. So always we should say, okay, for how much kilometer, okay, we should give for service, okay, the bikes, or it may be cars, or it may be anything. So we should give the service as well as the maintenance for the customers. We should tell them, okay, for every except for every 2 months or 3 months, okay, they should give the service for the service for the car, and they should replace the engine oil. So everything we should tell them, because then only it will be easy for them, okay, so that the car may maintain for at least 10 years. Then it go for design for the robustness. What is robustness? I told you
So
robustness.
robustness, I think here is like ability to produce the same output again and again. There shouldn't be much difference in the first product and the second product while you're manufacturing.
Yes, good. So that is called a robustness. The quality of the product should be high. Okay, from first product to the 1,000 products. If the customer is asking the 1,000 products, all the 1,000 products should be have the same quality, same dimensions, same design. Okay, that is called as robustness. The ability of a system of to reduce variations while delivering the defined output. What I told you. Okay, if the customer is asking 1,000 products, the 1,000 products should be have the same quality of the tolerance, or the design, or it may be the materials used. Everything, okay, it should be same. So that's called as robustness. Then design for supply chain. What is the supply chain?
Supply chain is like the transfer of goods from one place to another. So that should be like designed in such a way that it takes you less cost, like less transportation cost. Like you're buying material from one place, you're transporting, you're storing it, and then you're using it.
Good, Sachin. Good. So anyway, that is one form of supply chain. That is output. So when you manufacture a product, when you want to supply to customers, okay, so that's also supply chain. And within the company, okay, you'll be having the supply chain. Like, when you manufacture a component, okay, then it will go for assembly, right? So first we'll manufacture the parts, okay, in one department. Then again it will go for assembling in the other department, right, Sachin?
Yes, sir.
So this is called supply chain. So we'll manufacture at one department. If you take a car, example car, so there'll be number of parts will be there. I told you in the previous class, from engine to the wheel. Okay, if you assume from engine to the wheel, so there'll be around 30 to 40 parts. Okay, so practically, so 30 to 40 departments will be there. They'll manufacture the products. Okay, then they'll supply for that is assembling department, to assemble and make a car, right? This is called as the supply chain. So the design of supply chain should be good. So see example, in one department, if they're manufacturing 10 engines within 10 hours, the other department should also manufacture 10, at least 10 parts, okay, so that they can send the 10 parts easily to the assembled department, so that they will assemble and they will make a car. So this is called supply chain. So all the components, okay, they should go to assemble, okay, with respect to time, the same time. If they give like 10 hours, okay, whatever they ask regarding to the department, they should manufacture and they should send to the assembled department area, right? Then design for safety. What is this design for safety?
So the example can be like while you're riding a car and at high speed you crash. So you have
Yes,
that, no, so the airbags.
their access. So that's called as design for safety. Always you should remember the design for safety should be there, okay, in every application. If you go for any application, either in airplane, or it may be cars, or it may be any bikes, okay, everything, okay, you should consider this safety, okay. So in whatever the system told, that is airbags in the cars, Okay, if you go for the bikes, okay, we should wear the helmets. So these are called as safety. Okay, safety in the sense of you can tell design oriented towards controlling safety standards and the prevention of malfunctions during use. So that indicates, okay, regarding to the I told you about this one, right? The standards, that's ISO standards. So we should make a product, okay, which should apply for that ISO standards, so that the customers will be having more safety. Okay, so this indicate design for safety. So we'll be looking into one by one. So I think whatever I've told you here, okay, it's similar, right? It's similar here.
Yes, sir.
The design for manufacturing
So I
assembly, design
think
for
there are two new
reliability.
things, sir.
Yes, then design for machine ability, design for
Design for
serviceability.
environment.
So that's
Environment
very,
is
very
there.
important. So what does that indicates design for environment? Can you tell
So
me?
you need to choose material in such a way that when you're decomposing it, it doesn't affect the environment, or while you're using it, it doesn't affect the environment. Like you can see electric bikes compared to petroleum bikes.
Yes. So that is one example, best example. So because of the petrol engines or diesel engines, okay, more what you can say, more environment is means more pollution is coming, right? With respect to the, if you go for electrical bike, so there's no means pollution, right?
Yes, sir. While using it, yes, sir.
Yes, so this is called as with respect to environment. We should not use more plastics. If you use more plastic, we cannot do the to recycling. So that's also called as environment. So whatever the materials we are using or products we are using, okay, it should not what you can say, it should not give more means harmfulness for the means environment. So that is what is called as design for the environment. Then design for life cycles cost. So this indicates for overall cost of the product. Okay, for individual products, then we should assemble for all the products. So this indicates design for life cycle cost. So if you see here at the end, so you can see at the end, okay, I have added a definition, or you can say the design for X. Okay, this scenario leads to the development of the design by team approach known as concurrent or simultaneous engineering. So the first thing is, okay, to make a better product, the first is concurrent engineering. Okay, we should, all the departments, it should be conveyed in the same room, so that it will be easy for deciding, right? In every accept, they can decide easily. Okay, that is called as a concurrent engineering. I explained in the previous class. Okay, we should follow the concurrent engineering first. Okay, for the first time, stakeholders in the design functions had a voice in how a product or process was designed. With fully cross-functional design team is placed, organization could begin improving the efficiency and effectiveness of design to benefit both the organization and the customers. So what is the meaning of this? What is meant by stakeholder students?
So stakeholders can be like the investors who are investing in your thing.
Good.
So the thing is like if all of them are involved together, so like when they're saying the material, you can say like this will cost you this much. So the stakeholders can take decision there itself. So they can
Yes.
select the material based on the budget given to them.
Yes.
And on other process also like they have interconnection. Like if they are giving some function, is it possible not? The design team can say like it won't withstand this load, so you can change the material or change the design based on it.
Good. Stakeholder indicates everyone, right? Employees in the company, you can who are investing in the company, CEO, then who are working like managers, everyone. Okay, everyone. Okay, should be there when you are producing a new product development, or when you are producing a new product. Then it will be easy for for everyone to take the decision. Whatever the Sachin told with regarding to the cost, with regarding to the material, with regarding to the design, everything, okay, they can take the decision, okay, within like they can spend around 3 hours, and they can try to give a better product or good design product. Okay, because everyone will be there in the same room, and it will be easy for them, okay, to reach the customers. Okay, so that they can ask the customers, okay, this is the material I'm using, so this is the cost. Okay, so everything they'll be telling for the customers, as well as for the employees, and the employees can react. Okay, so if you use this material, whether we can make a design or not. If you go for drawing, extrusion and all, it will be very, very difficult process. Okay, so so that okay, the employees can tell their whatever they're thinking, whether if you use this material, whether you can manufacture the product or not. So everything, okay, everything will be discussing in the same same time, so that it will be easy for everyone to take the decision. So this is called as concurrent engineering. So if you follow these rules, the concurrent engineering, so then we can make a better product, and we can supply for the customers, as well as the customers can so they can react, okay, about everything, about the design, about the cost, about the materials. There itself, okay, they can tell whatever they want, okay, so that the organization also, they can improve the efficiency in the sense of they can improve the quality of the product, okay, they can reduce the cost, and they can get high profit, okay. Then so this indicates, okay, the organization as well as the customers, okay, can feel happy, okay. This indicates the design for X tool, okay. If they follow all these 9 design for X, then it will be good for both customers as well as the organization, okay. Next we'll go for next slide. Okay, problems demanding DFX. So what are the problems so that demand DFX means? So you can see there are around 10. Okay, I have written about 10 points. Can anyone say what is the first point? Equipment not currently available. What's the meaning of that? Problems
So
demanding
like you
DFX.
need to design based on equipments you have. So like for manufacturing process, you can't simply say like you require this machine, because the investment cost for the machine is too high. So you need to design based on the machines you already have.
Yes, good. So see, equipment not currently available in the sense of in the industry, in their company. Okay, if they want to manufacture some product, okay, X product, if they want some good level machines, or you can go for advanced machine. Okay, if they're not having, okay, they cannot invest that much money. So this is called as first. So why we should go for DFX? That is design for excellence. Okay, that is first one thing. First is nothing but the equipment not currently available. So in their company, if the equipment or the machines are not available, what they will do? So how they can give better product, okay, without using this equipment. So that is the first one. So that is the first point, right? So example, if you are a product design engineer, okay, assume if you are working in the industry, okay, if they tell, okay, use this machine because the other companies are using that's Y machine for the X producing the products, but in your company it is not having. So what you will do at that particular point? So what you will do, Sachin?
So can you
So
repeat the question, sir?
see, other company is using some Y machine, okay, Y advanced machine to manufacture a product, but that machine, okay, in your company it is not means it is not there. So what you will do as a product design engineer at that
So
particular point?
like there is a possibility, like if you're just developing a product, you can give subcontract to the other company, like parts of the like if you're just producing a batch of like some 100 or 200 components. So for that you don't need to actually buy the machine. You can give like separate parts to different companies and get it manufactured, and then
Okay.
test it and see if the demand goes high, and if you can earn the profit back, then you'll purchase the machine, or else it won't be required.
Okay, so this is very important. Okay, as a product design engineer, you should take the decision whether we should buy a machine, whether we should buy that new machine, or we should give the subcontract. Whatever the system told, which we can give subcontract regarding to the numbers. Okay, if they ask for 100 numbers, so there is no record for buying a new machine. Okay, we can give the subcontract for the other company, so that they will manufacture and they will give the products for us. So this is one thing. So if you get lot of like 1 lakh, 2 lakhs, or 20 lakhs products to manufacture at that particular point, as a product design engineer, you should think. So if I invest like 2 crores rupees for this product, how much I can get? Okay, once I manufacture like 2 lakhs products, so that how much I'll get the profit. So you should think all these things, and you should say for your CEO. So this is for this first. Okay, that is called as equipment not our current well. Okay, regarding to that, okay, we should go for DFX, design for excellence. So if you're not having the machines in your company, what you are going to do? So that is first problem. Okay, next you can go for methods unfamiliar to the manufacturing or assembly workforce. So what is that? What is the meaning of that?
So like based on the labor you have, like in which they are skilled, you can only use those machines. Like if you have like example given in this itself, sir. Like the people who are skilled in only manual soldering can't be good in
Yes.
automated. They need to have been trained for that.
Yes.
They need to design and like give steps based on what they can do.
Yes, that is the second problem. So if example, if I think if you go for around 40 to 45 years employees, so they don't know so they don't know how to use the technical equipments, right? Because they'll be using only manual. If you go for lathe or CNC machines, example, if you go for a small scale industry, okay, who is working under lathe from last 20 to 30 years, okay, they will not come for the advanced machine because they don't know how to use, right? So depending upon how the employees are thinking, and how they are familiar with the uh, with the machines, okay, we should give regarding to that, right? So this is called a second. The second problem is regarding to the employees. So who are working around 20 years or 25 years from the past. So that for them it will be difficult, right? And third is expensive fixtures. What is this expensive fixtures?
The fixtures are is it those things which like hold the
Yes.
particular product, sir?
Yes, yes, yes. So fixture
Like in
nothing but
we have
holding
in
the.
CNC not sir, like in lathe machine we have fixtures which like holds the tool.
Yes.
Okay,
So
okay, fine.
if you go for the lathe machine, that is a spindle. Spindle is used for fixing, right? Fixing the workpiece. So those are called as fixtures. So if you go for manufacturing castings, okay, you're casting your largest components. Okay, we should go for casting. If you go for bed for manufacturing your parts of the lathe like spindle and all, we should go for the casting method. So there we want the fixtures. So there also we should invest more, right? If they give if you go for a new product development or new product, then we should go uh, for producing the expensive fixtures, right? So it costs more. So this is also a question for us. If you go for industry, this is also a question. So they will ask, the CEO will ask for you if you go for new product. So what type of fixtures? Okay, you are going to use, whether that cost will be high or not. So you should tell all these things, not only about the product. Okay, you should tell about the fixtures also. So what type of fixtures you will be using for manufacturing a product. Then the fourth one is the specialized tooling. What is the specialized tooling? Students, can you hear me? Specialized tooling. So what is the
So I
specialized
think
tooling?
tools that are specific only for a product, it won't be used for other products much.
Okay, good. So if you go for manufacturing some product, okay, specifically they will tell we want these type of tools to manufacture this product. So that's called specialized. So that is called as specifically, okay, the tool that will be used for the producing of that product. So that also we should invest more. Okay. Then workplace redesign. What is this workplace redesign?
So workplace redesign is like assume you're a mass production company and they are giving you batch production, so it doesn't make sense. So you might need to reconvert it, yours into like a smaller place because keeping a bigger place you won't be making much profit. For batch production, you won't require that many systems compared to the mass production systems.
Okay, good. So that is called workplace redesign. So always you should design regarding to the products, how much the customers are giving for us. Okay, if they give like 1,000 products or 2 lakhs, 3 lakhs, so then it will be difficult to keep in one place. So then we should redesign our workplace. So keeping the 2 lakhs or 3 lakhs in the mind. So where we can place the output of the product, okay, in some way. So that's called workplace. So workplace redesign is but regarding to the customer requirements. So we should redesign the layout of the what you can say redesign of the workplace. Then go for operators assembly workers to use then asymmetrical motions. Okay, then limited and then limited the accessibility. What is that limited? Can you tell me? What is that limited access? The accessibility.
So I think is it like a kind of like a restriction, like you can only use this machine for 12 hours, then you need to give this machine like rest for 3 hours for it
Yes.
to function properly.
So that's called as limited accessibility. So if you go for industry, okay, these are the things. Okay, you should ask by yourself. Okay, workplace redesign according to the customers what they asking about the specialized tooling, then expensive fixture, then go for equipment not currently available, then limited accessibility. So that indicates how much hour the machines can work, how much hours we should keep idle. So we cannot work machine for 24 hours. So it will be very difficult for the machine, okay, to sustain that much work for 24 hours. Okay, at least we should give around half an hour, 30 minutes break for the machines. And then and next we can go for hard to find parts. So if you want to manufacture a part, okay, so we should buy the materials, right? And we should and if they ask, if the customer is asking a different or to consider the material, then it will be difficult, right? So depending upon the what the customer is asking, so how to find parts means to find the materials, okay, in the market. So it will be very difficult. Then special manufacturing operators or assembly worker skills. So to find the what you can say to find uh, the operator, okay, the technical operator, it's very difficult. If you open a example, if you want to open a new company, okay, to find the specialist operator or technical operator, it's very difficult in small scale industries. So I think it's very difficult if you go for the small scale industries, okay, who is working, who's taken the CNC machines. So for them, it is very difficult to find the specialized, or you can go for technical operator like CNC programming. Assume, okay, there's a lot of needs, okay, for CNC operator or CNC programmer, okay, in the small scale industries. Okay, if you go for Google and if you type CNC operator or CNC programmer, okay, you will get lot of jobs. Okay, you type and you see now. So in small scale industries, or if you go for the company, okay, the MNCs also, they are asking lot of CNC operator or CNC programmer. Okay, students. So this called as it's very difficult to find the specialist or the technical operator, okay, in the industry. I think there are a lot of jobs are there. Okay, but the students are not means they're not learning the properly. If you go for CNC programming, okay, they will not learn, they will not try to understand the concept. Okay, they will not try to write the programs with respect to needs of the CEO or the entrepreneur. Okay, so next, if you go for next, the tolerance beyond that which can be achieved given the available equipment or process. What is this? What is the tolerance beyond that which can be achieved given the available equipment or processes? Students?
So I think is it like you need to have a certain equipment to get the product under certain tolerance?
Okay, good. So see, within by using the equipment, okay, we should give, so whatever the tolerance they're giving, like 21.01 mm or 25.02 mm, whatever the customer is asking regarding to that, we should give the tolerance. So always we cannot achieve, okay, the same by using the manual. Okay, if you go for manual manufacturing the method, so it's very difficult. Okay, like if you go for CNC and lathe, so in lathe almost for 100 parts, for 100 manufacturing parts, at least 2 to 3, okay, it will be wasted. Okay, almost 97, I think 92, 95%, okay, you can get results, but almost 5 to 6 parts, okay, it will be wasted in the manual. But if you go for CNC, I think 98% it will be okay. Okay, regarding to the technical, what you can say, the equipment, okay, depending upon the equipment what you're using, you will get the tolerance, okay, according to the customer needs. So I think we should go the special manufacturing or operators are assembling worker skills, so it's very important in the industry. So if a worker has more technical knowledge as well as the technical writing the programming, so it will be good for a person. Okay, then you will get job easily. Then you can go for, so these are the problems. Okay, so these are the problems you should remember when you go for the industry, okay, to manufacture a good product. So these are the problems, okay, what they will face, okay, in the company. I think everyone has understood, right? So these are the specific problems, so that will be facing in the industry. So only we want this DFX, okay, design for excellence. I think everyone has understood. So anyone has any doubts?
No doubt, sir.
Okay, then we'll go for first one, design for manufacturing and assembly. So in this you can see what they will do in this design for manufacturing assembly, okay, method. So you can see first one is consider during concept stage to reduce the cost of redesign later, right? So what is the meaning of this? Anyone?
Sir, like when you are doing a rough sketch itself, sir. Based on that itself, you need to think like how you can reduce the number of parts or number of others the material, or like based on the assembly, or like based on the what do you say, yeah, those things, sir. So if you design at what do you say, if you make changes at the concept stage itself, sir, it prevents you from wasting money while you're producing it. Like usually after producing it one or two components, you're usually actually wasting a little bit of money.
Okay.
So instead of that, you can just correct the concept stage at start.
Okay, good. So this is in design for manufacturing and assembly. Okay, first one is in the concept stage only. We will try to reduce the cost of redesign. I mean, that is at the first stage only. We should give a good design for the company. Okay, after say once it goes from the concept stage to the your embodiment stage and detailed design. Okay, then at that detailed design. Okay, if the design is not good, again we should come for concept design. So we will waste that time and cost. Okay, cost of investing. So in the design for manufacturing, we should look these things, and we can go for the second one in involvement of manufacturing engineers and supply chain management at concept phase. So the as a manufacturing engineer as well as the supply chain management, okay, all the I think in concurrent engineering, whatever I told you, okay, everyone should sit together and they should finalize the design, right? And third is you can see involve investing waste. So we should check, okay, how much we are investing the cost for buying the material, okay, for manufacturing the products, okay, how much we are investing. So everything will come under the third one. And then next is reducing number of that is standalone parts. What is this? What is this? Reducing number of standalone parts. Can anyone tell me?
I think it is just reducing the number of parts, sir.
Okay.
Like making your assembly easier. Like if you have
Okay.
less parts, it's easy to assemble.
Good. So if you go, if you go for manufacturing of helmet, your new product helmet. So how much parts? Okay, how much parts you need for manufacturing the helmet? Either you go for 2 parts, or you can go for 3 parts, or you can go for 4 parts. Okay, you can go for 10 parts also. Okay, this is called as reducing number of parts. Means how you can reduce to manufacture a helmet. Okay, how you can reduce from 10 parts to one or 2 parts. So that you can do in this one. Okay, so if all the department head will be sitting there and they'll be checking. Okay, how much parts is required to manufacture this product, whether 2 parts, whether 3 parts, or it will go for 4 parts or 5 parts. Okay, now you can see when you compare from the what you can say your petrol car to the electrical car. Okay, how much parts has been reduced? Okay, you can see, you can type and you can see how much part has been reduced right now from petrol car to the, or you can see diesel car to the electrical cars. Okay, you see and you try to give the answer. Okay, how much parts has been reduced. So this is about a concept. Okay, while doing the concept base, okay, there only they will try to reduce the parts. Next, you can go for design for assembly. DFA indicates design for assembly. Time, identifying cost of assembly and efficiency. Okay, in DFA, so they will be trying to analyze the cost. So how much cost is required to assemble the parts, as well as how much efficiency, okay, that product will be giving. Okay, after assembling. Then investigate alternative through experiment. What is this? What is this? Investigate alternatives through experimentation. What is it, students?
So like giving the same design, like different options of like assembly or those things, and experimenting like which will take less components or less parts to produce it, or like based on the time taken for it to manufacture.
Okay. Okay, good, Sachin. So this indicates, say, once you assemble the products and if you check the efficiency, okay, in some part, okay, you assume, okay, after manufacturing, okay, you are getting less efficiency, okay, so that immediately they can investigate and they can go for alternatives. Okay, after experimentation, they can go for they can redesign some part. Okay, if this part is giving error for us, so what we will do? So we will go for another design and we will replace there, right? So that is called as after investigation we should do alternatives, okay, for the design. Okay, next is error proofing POKVK. So this is a method, okay, you check in the Google what is POKVK. So POKVK is a method of this is nothing but a technique. Okay, technique, or you can call this as a tool. Okay, which you'll use to what you can say to update all these things. That is DFA, investigation, or involving investigating waste. So everything we can use this PokeWiki method, and we can eliminate these things. Okay, this is called as design for manufacturing and assembly. Okay, this is first one. This is a first process. Okay, which we should check in the design for excellence. Then what is reliability? So this is called as quality over a period of time. Whatever this thing has told, it is same. So every time, okay, for manufacturing 1,000 products, okay, the quality should be same. So that is called as quality over a period of time. The ability of an item to perform a required function under stated condition for a stated period of time. So what is the meaning of this?
So its ability to perform the same with respect to time, sir. Like for a long duration, assume the car is working like giving a mileage of 50 kilometers per liter today, and
Yes.
even after 2 years, it's giving almost the same mileage.
Okay.
Then it's a reliable product.
Good. But in practical cases, okay, so this is not possible. So initially you will get like 60 or 60, maximum 60 for 150 for 125 cc bikes. That it may give on 55. So if time goes, okay, the mileage will reduce. So if it gives same function like 50 kilometers per liter, so that indicates, okay, it is more reliability. It has more means reliable. So that indicates for a specific time, for specific condition, okay, it satisfies the same function. So that's called as reliable. So like 2 years or 5 years, okay, if it is giving 50 kilometers per liter, so that's called as whatever, okay, the company has told the product as this function. Okay, if it is giving for that much time, so that is called as, okay, the quality is better in that product. Then design for reliability. Then we'll go for next one, design for reliability. Analyze load strength relationship. What is this? What is this? First, analyze load strength relationship. Anyone? What is
So
this?
is it like some kind of test, like where you put a certain amount of load and see how the product functions under that condition?
Yes. The first is analyze load strength relationship. So apply some load to the some load, not some load, regarding to that application. Okay, we will apply the load. Okay, regarding to that application, and we will see the strength of the product. So first is this is very important. Okay, design for reliability. When you go for the engine design, okay, manufacturing of the engine design, okay, we should check the wear. Okay, how much wear is, see if it runs around 60 or 80 kilometers per hour, so what will be the weight, okay, which will be causing, okay, in the cylinder. So and what you can say, what is the temperature, okay, which is coming on the cylinder. So due to that, what is the maximum stress, okay, that will be developed in the cylinder. So everything we should do this analysis. So this is called analyze load strength relationship regarding to that application. Then you can go for design out inherent weaknesses. So we should see what are the weaknesses, okay, of the product. So you can say analyze potential failure mechanisms and remove, right? So we should try to remove all these things, right? When you see that load which is strength, when you apply the load, and when you see the stress, okay, which is developed inside the material, if it is more, what we should do, students? So what we should do?
So like if the stresses are more, you need to redesign it, sir.
That's good. So that is what it is called as analyze potential failure mechanisms. So when it fails, okay, due to that load, then we should go for redesign the model. Okay. So that is called as first one. So analyze potential failure modes. So we should see the failure modes. What is it called as modes? I think you studied in mechanical vibration.
So mechanical vibrations, sir, I think
The
modes
first
might
mode,
be
second
like
mode.
breaking apart into several components, sir.
Okay.
Wait, analyze potential failure modes. Not sure, sir. I was
Okay.
actually saying about nodes, sir.
No, modes is nothing but so I think you've seen you've seen in mechanical vibration, right? The first mode, second mode, third mode. Yeah, I think you've done in the
Yes, yes, sir. In
fourth
vibrations, we
model and
have
fifth
seen, sir.
model.
First mode
Yes,
of
that's
vibration,
to
second mode of
find
the
the
loop, sir. Wave.
to find the natural frequencies for the first mode, second mode, third mode, right? So we should
Yes, sir.
see.
Yes, sir.
So we should see in which natural frequency the material is failing or not. So this is called as analyze potential failure modes. So this is very important. So due to the vibration also, okay, the material can get failure. See fatigue, then vibration due to the natural frequency. When the natural frequency is equal to the force frequency, then resonance occurs. So see all these things we should consider. Okay, then past data. What is this past data?
So like in past, what happened, like when you did it in such a way, how did it react? Like how did the product function based on that? So if it has functioned bad, like you take that information and don't again do the same thing. You make
Yes.
changes to the earlier existing data.
Okay, good. So this is about past data. So that indicates, okay, we always when you're doing some analysis, we should take the past data. That is previous history from last 3 years. Okay, what are the different types of analysis they are done? So what is the force? What's the load they are given? What is the fatigue load they are given? So what is the creep? Whatever the analysis what we are doing, we should see the past data from in the company. Then only we can analyze and we can analyze and we can say, okay, this much load the metal can stand. Okay, then next we can go for plan for reliability improvement and plan correct testing. So after this thing, then we can improve the quality of the material, right?
Yes, sir.
So then it will come for plan correct testing. So then we'll go for the testing. So then next slide, from next slide we will try to analyze in the next class. What is this? Okay. So I think why okay this after this, okay. If I do this much, okay, this completes your design for X. I'll stop sharing this screen. I'll take don't do the class. I'll take the attendance. Okay, wait for 2 seconds. If you have doubts, anyone, if you have doubts regarding to this to today class, you can ask the students. Okay. So no doubt, students.
No doubt, sir.
Okay. Okay. Thanks. You can leave the class. Okay. If you have doubts, you can call me later. Thank you.
Thank you, sir.
Yeah, thank you.